Hello again. We're going to do some more implicit derivative practice. So here we're asked to find the derivative, and we're going to find the derivative with respect to theta, right? So that's important to pay attention to because that says with respect to the variable theta. So when I go and differentiate this function, cosine r plus cotangent theta equals r, I'm going to differentiate with respect to theta. So taking the derivative, we're going to be taking the derivative of each of these terms with respect to theta. And so if we take the derivative of a variable, which is not theta, then we're going to write dr d theta behind it. So the derivative of cosine is negative sine. So I've got negative sine r, and I took the derivative of r, so I write dr d theta, the derivative of r with respect to theta. The derivative of cotangent is negative cosecant squared. So here we're going to say minus cosecant squared theta. And that's just a property. We know that the derivative of cotangent is negative cosecant squared. And since I took the derivative of theta, I don't need to write dr d theta behind it. Essentially, again, think about this. It's like I did d theta. So in that regard, we don't need that there because that's more or less just equal to 1. And then the derivative of r is 1, right? This derivative right here, the derivative of r is 1, but since I took the derivative of r with respect to theta, I'm going to write dr d theta. And at this point, we're done with the derivative, but we do need to isolate this dr d theta because that's what we were asked to find, dr d theta. So in order for me to isolate here, I'm going to collect terms. And I might leave this negative cosecant squared theta equals dr d theta plus sine r dr d theta. So I've put both of those dr d thetas on the same side. And at this point, once we've collected, then we can factor that GCF. So I've got negative cosecant squared theta equals dr d theta. I've factored it out, and what I'm left with is 1 plus sine r. So in working to determine my derivative, what I end up with here is that negative cosecant squared theta over 1 plus sine r is equal to dr d theta. Okay, so we're going to do this again. We're going to find the first and second derivatives. So thinking about what the first derivative looks like using this differential notation, we get dy dx. And then my second derivative is d2y over dx2. Like that. So we're going to find both of those derivatives. And you can use y or y double prime. I personally, y prime like that. I just, as we move ahead, and again, getting into Calculus 2, making sure we understand the notation. So this is, the prime notation is a really shorthand way of saying what I've written there. Okay, so we're going to find the first derivative, and we're going to differentiate with respect to x. So d dx of 3 plus d dx of sine y equals d dx of y minus d dx of x cubed. So taking the derivative of each term, derivative of 3 is going to be 0 because the derivative of a constant is 0. The derivative of sine is cosine y, and again, because we take the derivative of y with respect to x, we need to write that's what we did. The derivative of y is going to become just 1, which we don't need to write, but I will write for continuity. And since I took the derivative of y with respect to x, we write dy dx. And then the last piece here, we've got 3x squared. So at this point, we're done taking the derivative, but we want to go through and isolate this dy dx. So isolating that, I'm going to move some terms around, and I end up here with cosine y dy dx minus dy dx equals negative 3x squared. So I moved one term over. I'll factor that GCF out. Dy dx equals, let's see, dy dx times cosine y minus 1 equals negative 3x squared. And don't forget about that 1 there. So dy dx is negative 3x squared, or cosine y minus 1. And, you know, depending on how you arranged this, you could have also had dy dx equals 3x squared over 1 minus cosine y. Either of those are acceptable. It's just dealing with that negative on rational functions. All right? But both are okay. So now what we're going to do is we're going to take the second derivative. This guy right here that we're looking at represents my first derivative. So moving along, we have the original implicit function. And then we've got our first derivative, okay? So the problem asks us to find the first derivative and the second derivative, and the second derivative is just taking the derivative again of that first derivative. So looking at finding this second derivative, what we're going to be doing here is we're going to be doing d dx of dy dx. And so hopefully that, thinking about it that way, that helps you see why we write d squared y over dx squared like that. It's part of our notation. All right, so we're going to find the second derivative, and in order to find the second derivative, looking at what we have here, we see a quotient rule. This guy right here is a quotient. We're taking the derivative of a quotient. So remembering your derivative of a quotient, d dx of something, a top and a bottom, numerator and a denominator, we would write bottom t prime minus top b prime over the entire bottom squared. So we're going to use that pattern to find our second derivative. So in this case, d2y dx squared. My bottom is cosine y minus 1. The derivative of my top, 3x squared, is negative 6x minus negative 3x squared. And the derivative of my bottom, cosine y minus 1, derivative of cosine is negative sine y. I took the derivative of y, so I write dy dx, and the derivative of 1 is 0, so we don't really need to write that there. All of this is over the quantity cosine y minus 1 squared. All right, so we started with that derivative up there, and we've taken the second derivative. And what I want you to notice is we have a dy dx inside our second derivative. So eventually, we're going to need to use this and plug it back in there to simplify. We can do that early on. We can do it later on. It's just a little bit of algebra in order to get this correct. All right, so working into some simplifying here. I've got negative 6x cosine y plus 6x, And then if we look at these minuses, minus, 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 that 0 doesn't need to be there. So minus, 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 2 negatives make a positive, another negative. We'll turn that back negative again. So we've got negative 3x squared sine y dy dx. And all of that is still over cosine y minus 1 quantity squared. So remember, we know what this is from up above. I can plug that back in. So at this point, I'm going to put that in, and we'll multiply by 1 to clear that fraction to simplify our problem. So my second derivative is negative 6x cosine y plus 6x minus 3x squared sine y. And then what I'm plugging in is negative 3x squared over cosine y minus 1. Again, all of this is still over that entire denominator squared. So now that we're into the algebra meat of the problem, it's just a bunch of simplifying to clean it up. This is going to turn into 9x to the 4th sine y over cosine y minus 1. So cosine y minus 1 squared is in the denominator. And what you want to pay attention to is that dy dx was only multiplied by the 3x squared sine y. So it's only attached to that term. But we have this ugly little fraction inside of our fraction, and we need that to go away. So what we do is we multiply by 1, and we form that 1 by looking at the denominator. So I've got this big fraction. I'm going to multiply by cosine y minus 1 over cosine y minus 1. And when I do that, what that's going to do is that's going to distribute across the top. Now this is multiplying by all of it, and so I'm going to have to multiply that into 3 terms. So I've got y double prime equals negative 6x cosine y times cosine y minus 1 plus 6x times cosine y minus 1 plus 9x to the 4th sine y. And then all of that, since I had 2 of them in the bottom and I've multiplied by a third one, I now have cosine y minus 1 cubed. Okay, so that's the tricky part to see what to do. And now it's just a matter of distribute, clean up, combine any like terms as necessary. So I've got negative 6x. I'm distributing here. I've got cosine squared y plus 6x cosine y plus 6x cosine y minus 6x and plus 9x to the 4th sine y all over the denominator squared, or cubed now. And really we just have these 2 terms in here that we can combine, and then I can also factor a GCF out. So simplifying this, I have negative 6x cosine squared y plus 12x cosine y minus 6x plus 9x to the 4th sine y over cosine y minus 1 cubed. So all we did was condense those 2 terms to get that 1 term there in the middle. And at this point, our last step for finding that second derivative would be to factor a negative 3x out. I can pull 3x out of all of the terms. They all have a 3x hiding in them. So if I pull that 3x out, and I'll use a negative 3x, that leaves me with 2x cosine squared y, negative 3x, that gives me minus 4 cosine y, negative 3x, plus 2, negative 3x is minus 3x cubed sine y, all over that denominator, cosine y minus 1 quantity cubed. And I was about to say that is my final answer, but I'm noticing right in here in front of this cosine squared, we should just have a positive 2, not a 2x. So I'm going to correct that. I had a 2x there. I'm going to turn that into a 2 because this was not an x squared term that we started with. But here we have our answer, as concise as we can make it. Please email me if you have any questions. Thanks.